Okay, this is an overview for all of the different types of factoring that you could be encountering in this chapter that we've been doing in chapter 5. The thing about the test that you have coming up is they don't divide the problems into sections. They just put the problems on the pages, and each problem will just say factor completely. So you have to be able to diagnose the difference between each problem and what they'll have to be doing. So this paper will be a valuable tool for you. If you're still having trouble with some of this, then these are the video links to go watch the videos that will help you with this factoring. Okay, the first ones, I went over these first two in class the other day, but I'm going to go ahead and go back with them on the video for those people that haven't been in class. So the first method is the overall method for greatest common factor. It's the first thing you should always try when you're doing a problem that just says factor. A greatest common factor can be any amount of terms for a polynomial. So 2 terms, 3 terms, 4 terms, 5 terms. So this one is the one that you should always try first. You should always look and see, is there a greatest common factor? And if there is, you should go ahead and factor it out. If what's left has something else that would fit one of the other categories, then you have to go ahead and continue to break it down if it's possible. In the case of these 3 problems, you wouldn't have to break it down. There are some at the bottom that we'll do, and we'll show you with how to work with the greatest common factor and then keep going. So in the first one here, we're looking for the greatest common numerical factor. So 6, 9, and 18, the largest thing that would go into all 3 of them would be a 3. So I'm going to take a 3. They all have x's. So when you work with the variables, you would always take the lowest power of that variable. So the most x's I could take out would be 1, x to the first. That's the most that could come out of all of them. And then they all have y's, and so the lowest power on the y's would be a y to the first. So I'm going to take the 3xy and I'm going to divide it out of each of the terms that are there. And the leftovers is going to go in the blanks, in the parentheses. So 6 divided by 3 would be 2. I have 4 x's here, and I'm going to divide out one of them, so that would be x to the third. Then I have a 1y, and I'm going to divide that y off. So really, y divided by y would be a 1, but multiplying by 1 won't change anything, so we just use it to x to the third. Then I go to the next one, 9 divided by 3, so the numbers are going to divide. That would be a 3. Here, the x's are going to reduce out completely to 1, and y to the fourth, get rid of one of them, would leave y to the third. Then I'm going to go to the last term, and I have negative 18 divided by 3, that'll be negative 6. I have 3 x's, get rid of 1, so that's going to be x squared, and y cubed, to get rid of 1, would be y squared. So in this case, this set of parentheses doesn't have anything else that we could do to it, so this would be your final answer. Okay, so problem B, we'd look at that and we'd look to see, well, they all have a numerical factor of 5, so I'm going to take the 5 out. And they all have x's, and the lowest power would be x to the first. So my common factor will be 5x. Then I'm going to divide that into each term and take what's left over. So here I'll have 2x squared, because I'm getting rid of one of the x's. Here I'll have 15 divided by 5 would be 3 just x, because I have 2, get rid of 1. And then 5x divided by the 5x, it doesn't disintegrate. It doesn't go to nothing. 5 divided by 5 would be 1, so I have to have that 1 there. Now here's another thing to remember. When you take out a greatest common factor, however many terms was in the problem to start with is how many terms you're going to have in the parentheses. So here I had 1, 2, 3 terms. My parentheses has to have 3 terms. Because really, this is what we're doing is reversing the distributive property. So now if we go back and distribute the 3xy, we'll get what we started with. If we go back here and distribute the 5x, we'll get what we started with. If you don't put that 1 there, there's no way you can generate the 5x to check it. Okay, number C is actually kind of here to lead you into the next section. So the greatest common factor here, they both have a term that's in parentheses. So the term that's in parentheses becomes the greatest common factor. That becomes the thing that they both have. So now if I divide that, it means this will go away, and that would leave me with 10y. If I divide this one, it will go away, and that leaves me with minus 9. Now, the most 2x plus 7s that I took out from each of these was only one of them. So that's why my 2x plus 7 is really just to the first power. Okay, number 2 factoring method, if you look at a problem and there's a greatest common factor, you take it out. Okay, then you look at what's left over. Now, a grouping problem can have a greatest common factor, but the problems that you have on your homework and in your test situation coming up is probably not likely that it's going to have a greatest common factor. A factoring by grouping problem, you're going to be able to identify it because it has 4 terms. So then when you see something with 4 terms, this is what you're going to use to do it. So here, what I'm going to do is, if I look, I don't have something that all terms can have a greatest common factor for. So what I do is I pair them up to see these two both can be divided by 2, and these two both can be divided with a y in it. So I'm going to take them separately, and I'm going to do the first 2, and I'm going to take out a 2, and that would be left with 5x squared plus 4. Now here, they both also have negatives. So I'm going to take that negative out as a -1 along with this y. So I'm going to have a -y when I take it out. And then when I divide out the negative off the 5 is going to divide and leave me with 5x squared. The negative on that 4 is going to divide out to the y, and it's going to leave me with plus 4. And notice here, your parentheses have to be the same, and that takes us back to this problem up here. So now our greatest common factor is this one thing, and I can take one of them, which would be 5x squared plus 4. I can take one away from each of these, and then the leftovers would simply be 2 minus y, the thing that's left out in front. Now, this little sign right here, this is important, okay? You've got to have that sign right there. If you leave that sign off, you won't know what you're supposed to do down here, because that sign is what shows up right here. So you got to have a sign in between. Okay, here's the same kind of problem. It's got 4 terms. I can't find a greatest common factor for everything, but I can if I pair it together. So if I put the 2xy with the 8x, they both have factors of 2, and they both have x's. Over here, I compare the 5y and the 20. They'll both divide by 5. So I'm going to keep them just like they are. If you can't find anything, you might have to rearrange the terms, and we had to do that in class on some of them. So I'm going to take out a 2 and an x, and that would leave me with y plus 4. Over here, I'm going to be looking for this same parentheses to show up. So I have a 5 and a 20. I can take out a positive 5, so I'll put the plus in front of that 5. I have to have that sign there. And divide the 5, and I'm left with y plus 4. So now y plus 4 becomes my greatest common factor, so I'm going to take 1 out of each one of them. And that leaves me with the 2x plus 5. So this would be your final answer. So grouping would be a problem that has 4 terms in it. You got to recognize it and know when you can use it. Factoring trinomials, there's a couple of different kinds. The first ones that we did, the number on the front of the squared term was a 1. I call those plain trinomials, okay? A trinomial is going to have 3 terms. Yes, it could have a greatest common factor because that works for any of them. But okay, these right here have 3 terms, but in these problems there are no greatest common factors. It's just teaching us how to do the trinomials. So a trinomial is an answer when you have 2 binomials that are being multiplied. So what we're trying to do is find what was multiplied together using FOIL to get these answers. So what I need to do is I need to look at the back term and know that the two numbers that were in the back of the parentheses is what got me the 63. The two numbers that got me x squared would have been my x and my x. So I'm always going to do that much of the problem first. Two sets of parentheses and x's or whatever the variable is in the front right there. Then I have to decide what was the numbers that got me the inner and the outer. These two for FOIL. That's the numbers that get you the 16 in the middle. So when I'm looking at this, I want to find what multiplies to get 63 that will add to be 16, because the signs are giving us clues. Okay, so if it's a plus here, the signs are going to be the same. This tells us what they're going to be. So I'm looking for factors of 63 that add up to 16. That would be 9 and 7. I'm going to put my biggest number in the first parentheses, and I'm always going to put the sign of the middle term with that. Then I'm going to go back and look. In order to get a positive 63 here, I would have to have a positive 9 times a positive 7, or a negative 9 times a negative 7. But the middle term's telling me that they both have to be the same, and they're both going to be positive. Okay, so I go over here. Same thought process. I need two sets of parentheses. I'm going to get the x squared with an x and an x. I need the factors of 33. Again, there's a plus, so it means add up to be 14. So 33, factors of 33 that add up to 14 would be 3 and 11. So I'm going to put my 11 in the front and the 3 in the back. The bigger number, the front number, the big number gets the minus sign. And this says they have to be the same. In order to get a positive 33, both of these numbers would have to be negative. So negative 11 and negative 3. Okay, over here, same concept, but this time that last sign is negative. So that means in order to get negative 48 from multiplying the last two terms in the parentheses, one of them has to be positive and one has to be negative. So the minus says the signs are different. But if the signs are different, then we have to subtract to get the middle term. So I'm going to still get my x squared with x and x. I need factors of 48 that subtract to give me 2. Well, there's 1 times 48, there's 2 times 24, 3 times 16, 4 times 12, 6 times 8. So I have to think about all the possibilities here. Well, 6 and 8 are going to be the two that subtract to give me a 2. The middle's positive, so I'm going to put the bigger number, the 8, with the 2 on it. Put that bigger number in the front. Just make it a habit to do that, because it's going to get the middle sign. This is telling me they have to be different, so the minus 6 goes in the back. Okay, and over here, my last one, I'm going to keep my x and my x. Then I'm going to look for the factors of 36 that subtract to give me 9. So 36 has a lot of factors. It's not 1 times 36. It's not going to be 2 times 18. We've got 3 times 12, 4 times 9, and 6 times 6. So I want the one that subtracts to get me 9. So it has to be this one. So I'm going to use 12 and 3. The big number gets the middle sign, so that's a minus. And because this says negative, these have to be different, so it'd be a plus on the 3. So I call these plain trinomials when you're working on these, because there's a 1 on the front. You don't have to concern yourself with any number in front of the x. You just work with the numbers that are at the back. Now that's great, but if there is a number on the front, then we have to consider what was the numbers that we used to get the 6 on the front of this x squared. So one of the methods that I showed you we call the rainbow method. So what you would do on these is, first of all, we would always look for a greatest common factor, because we would hope that that would divide off. But here we can't divide the 6 off. So I'm going to circle the 6, just make a habit out of doing the circle. Circle the 6, bring it back to the 2. So that gives me x squared plus 7x plus 12. Now I have a problem that just looks like a plain trinomial. So I'm going to just do ahead and do this one just like I did these up here. I'm looking for the factors of 12 that add up to 7. So that would be 4 and 3. And the big one's going to be a plus, but that says they both have to be plus. Okay, now here's what you have to do to finish this problem. This number that you circled and multiplied back here, we've got to come back and do something about that. So what you're going to do is you're going to go under these numbers and you're going to put that number that you circled right underneath there. Okay, then you're going to look at those fractions that are there. You have to reduce these fractions. If the fractions can divide out evenly, you're going to get a whole number here. Otherwise, you're going to get a reduced fraction. So this now becomes x plus 2/3 and x plus 1/2. Now, when the instructions say factor, we don't want these as fractions. So what you can do is you take your denominator number and you move it over in front of your x, and so we would just call that 3x plus 2. And over here you're going to take the 2 off the 1/2 and you're going to slide it over in front of that x, and we're going to call it 2x plus 1. So if we were to FOIL this back, 3x times 2x is going to give us the 6x squared. The 2 times 1 on the back is going to give us the 2, and the outer would be 3x, and the inner would be 4x, which would add up to the 7 that's in the middle. So you can't stop halfway in the middle of the rainbow problem. You've got to go all the way to the end. And so that means if there's a number on the front of the x squared term, you're going to end up with something in here that has a number on the front. It might be both of them, it might just be one of them. So it just depends on the problem. Okay, so over here, we look first and we see, I sure hope this 4 would divide off, but it won't. So we're going to circle the 4. We're going to bring it down and make it look like a rainbow. I'm going to slide over here. Then we'll have x squared minus 23x plus 60. So now I'm just going to factor this plain trinomial and have x and x. Factors of 60, there's quite a few of them, but I need to add up to 23. So I'm going to use, let's see, 3 times 20. How's that work? That would work right there. So the big number would be minus 20. The small number is going to be minus 3. So my outer would be negative 3. My inner would be negative 20. Yep, that checks for that right there. But I circled this 4. So now I got to come back and put the 4 underneath. When I simplify this one, it's just going to come out to be x minus 5. And over here, 3/4 is already in lowest terms. So I'm just going to slide that 4 over and write it as 4x minus 3. So this would be our final answer. Notice on this problem, all of the number for the front term was in one factor here. So it could have been 4 times 1 would make 4, but this case, and then it could have been a 2 times 2. So here we needed the whole 4 in the back parentheses. Okay? So those are 2 kinds of trinomials. One of them is when the first term, the term in the front of the x squared, is just a 1. Down here is when we have a number in front of that term. So you would have to look at that and make sure you finish the complete problem. Once you rainbow it, you got to come back and divide it back out. Okay, the next set of problems are special trinomials that result when we have the exact two factors that were being FOILed together. You can do these problems with the rainbow method, but because they result from something that's been squared, a binomial that's been written twice and FOILed out, they give you a special pattern. The first thing you notice is that the 9 and the 64 are squares. So we would have a square on the first term, so the first term would be squared. Then we can have a plus or a minus, and we'll have 2 times the product, 2 times the square root of the a and the c. Okay? You'll see that out. You'll see how that works out. 2 times, I'll put a dot right there. And then we have a plus always at the end, and then we'd have the square of the back number. So when the problem fits that category, we can look at it this way. I know to get the 9, I'm going to need a 3x and a 3x. And I know that to get 64, I can use 8 and 8. So if I put both of them as 8s and I put pluses on all of them, if I do my outer, that's 24, and my inner will be 24, which adds up to 48. So I know that these two have to be my factors. So you can go through, if you do the rainbow, 9 times 64 is going to give you a really, really big number, and it would work out for you. But if you look at the numbers first and you recognize, circle the 9, bring it back to the 64, and you get a big number, you need to go, wait, that's really big. Let me go back and look at this. So when you see a square number on the front and a square number on the back and a plus right here, then this is a possibility, and all you have to do is take square roots. So here I have 49 on the front, which is a square, 100 on the back, which is a square, and a plus at the back. Then that means this could be a really easy trinomial. So I would take this and do my parentheses. 49 would be 7y and 7y. Square root of 100 would be 10. So I have 10 and 10. It kind of didn't turn out good. And this says my signs have to be minuses, both of them. So when you do this, the parentheses are going to have the same term in them. They'll be exactly the same with the same signs. Whatever the middle sign is what's going to go there. So this time I have negative 10 times 7 would be negative 70, and the outer would be another negative 70, and 70 and 70 adds up to 140. So this is one that if you recognize the pattern, you can factor them really easily. Now it's also okay on these problems, because it's the same factor twice, you can also write it like that. So this one is the same as saying 7y minus 10 quantity squared. It's probably easier when you're doing it on the computer to just type it in, because here you don't have to write any exponents. That make that a little bit easier. Alright, number 4 method here is for factoring binomials. Okay, these are problems that only have 2 terms. Now, binomials also fall into this category up here. They can be a greatest common factor problem. So here's the thing. If the binomials, and this should have a squared on it right there, if the binomials are a square number minus a square term, then it could fit this category, okay? Because you're looking for a square number and an even power and a subtraction problem. If this is an addition problem, it does not work, okay? It has to be subtraction. So 4 things you have to have. First of all, it has to be a binomial, okay? It has to have 2 terms. It has to be subtraction, okay? It has to be perfect square numbers. Perfect, let me write that, square numbers, okay? Any numbers in the problem have to be perfect squares, and it has to have even powers. So this is what you would look for when you're looking for that. What do you look for when you're going to do it by grouping? You're going to look for something that has 4 terms. What are you going to look for when you want to do it by a difference of squares? This is called a difference of squares. So that's in your notes. Make sure you look at your notes when you're doing your quiz and your test. This would be a difference of squares. Okay, difference means subtract. Alright, this one's just like, almost like the one above it, except if the last term is negative right here, that means that my signs have to be different. Because that's the only way I can get negative 49 is to have 1 positive and 1 negative. So you look at the term. What's the square root of 36? Okay, so that'd be 6. Now, on the powers, what you do is just split them in half. So that would give me a 6t here and a 6t here. And in 49, the square root of 49 would be 7, and I'll split the ends. So I end up with 6t plus 7n and 6t minus 7n. Now on these, you can't write them as a squared because these 2 terms are different. Here, you have the exact same term twice. Here, they're different because the signs are different. So these have to be written individually. Okay, know your perfect square numbers. In class the other day, I made you write the perfect square numbers down so you'll recognize them. So here, I'm going to take the square root of 169, that's 13. To split up the 6 would give me x cubes. To split the y would just be a y to the first. 361, the square root of 361 is going to be 19, and that would be a z squared. I'm running out of room there. And over here it would be a minus 19z squared. I should have made my parentheses bigger. Okay, so this is the easiest kind of all. Two terms, has to be subtraction, they've got to be squares, and they got to be even powers. Alright, over here, this one is one where you have to be really careful. There's one like this in your homework too. You're gonna break it up, so this would be n squared and n squared. 16, the square root of 16 is 4 and 4, so I'm going to have a plus on one and a minus on the other one. But I have to continue working because this is a squared term, so you got to pay attention when it has a minus in it, because that means that's squared and that's a perfect square number. That means this piece right here will factor again. So I'm going to have n minus 2 and n plus 2. So anytime you have an n squared with a minus in it, you got to check it because you might have another difference of squares to work with. Then you just bring the n squared plus down as one term by itself. Okay, so this is one where you do have to keep going. As long as you keep having difference of squares, then that will continue to break down. Okay, at the bottom here, this is where you have problems that say factor completely. There are some in your homework that you've done, and so here's what you have to do. If there's a common factor, you're going to factor it out. And then you're going to factor what's left over by some of the methods up above that you've already used. Now, I don't see any of them here that have 4 terms, so nothing in here will be the grouping problem. Okay, I see a trinomial, I see a binomial, I see a trinomial, I see a binomial. So these are the things that I have to look and see first. Is there a common factor? So on this one, I'm going to look and see, wait, they'll all divide by 3, so I'm going to take a 3 out. I'll have y squared minus 3y minus 4. Then I'm going to look at what's left over. The 3 I'm just going to ignore for the time being. I'm going to work just with the trinomial. So I'm looking for a y and a y to get me y squared. I need the factors of 4 that subtract to get me a 3. So that has to be 4 and 1. So 4 is my bigger number. It's going to get the minus. And a 1 will get a plus because the signs have to be different. And then you bring your 3 down. And now if you FOIL this back together, you'll get this parentheses. Then if you multiply by 3, you'll get what you started with. So you should always be able to check by FOILing it back and multiplying by the number on front to make sure that you got the numbers right. Alright, number B also has a common factor. So I'm going to take a 2 from each one, and I have y squared minus 25. Then I have to look at what's there. That'll factor again because it fits the difference of squares. It's a binomial, it's 2 terms, it's subtraction, it's got perfect square numbers, and it's got even powers. So I got to keep working on this. So I'm going to have 2, and then have y, and the factors of 25 would be 5 and 5, and one's going to be plus and one's going to be minus. Doesn't matter which one you put the plus or the minus in. Okay, that would be your final answer, because your powers that are on the numbers in the parentheses are all first powers. Once you get down to first powers, there's nothing else you can do to it. Here we had a squared, so we had to keep going. Here we don't have a squared on these, and 5 is not a perfect square. Here we don't have a square on this y, so there's not a difference of squares, so that stays like it is. Okay, over here I can take a 2 out of each one of them. So first thing I'm going to do is take the 2, and then I'm going to look at what's left over. 2y squared plus 11y minus 21. Okay? Now, what I have left over in here is a trinomial that has a number on the front, so I'm going to have to go use my rainbow method. So I'm going to go back up to here where I did these problems. So now this problem has to be worked this way. So now I'm going to circle the 2 and bring it to the 21. Then I have y squared plus 11y minus 42. Okay, I'm looking for factors of 42 that subtract to get me 11. Factors of 42 that subtract to get me 11. I think that's 3 times 14, and that'll work. So I'll get y and y, a plus 14 and a minus on the 3. I circled a 2 to start with, so I'm going to come back and divide off that 2. That 14 will simplify out and be y plus 7. And the 2 is going to come out and become 2y minus 3. And I have to bring down that common factor that I had at the very beginning. So this one's more complicated because not only do you have to take out a greatest common factor, then you've got to go through all the steps of the rainbow. So this one's probably your hardest kind of problem to do. There will be some on your homework, and I'm pretty sure there's one like this on your test. All right, number D. I'm looking at here, and I can take a 5 out, and then I'll have x to the 4th minus 16. And then when I look, oh, that's the same number as that one. So I have 5, and then I have x squared plus 4 and x squared minus 4. My x squared minus 4 is still a difference of squares. It's just like this one. So this one has to continue to work. This one's done. So 5 x squared plus 4. And this one then would become x plus 2 and x minus 2. So this sheet of paper is important for you to have when you're doing your homework, and also when you're doing this test next week, because you'll have the test on later in the week, and this is something you need to have beside you when you're doing that test, so that you can always refer back to this based on the problem that they give you on your homework, on your test. So use this to your best advantage, and I hope that you'll be doing really well, because we're going to use a lot of factoring for the next couple of weeks when we start on chapter 6. All right, thanks, bye.